Hello students, welcome to Sri Jendra's Ring Zone classes. I'm your friend and mentor for coming classes with respect to physics. This is lecture number 3 of a unit Mechanical Properties of Fluids. So let's begin with today's class. In today's class we are going to discuss about the Archimedes principle. So what Archimedes principle is, as you have learned this in the class number 9 too, it says that it's an Archimedes principle. It says that if a body is submerged fully or partially, submerged fully or partially in a fluid, then fluid will exert fluid will exert a certain amount of force on the body in the upward direction. And we understand that this force is known as the upthrust or buoyancy force. Yes, this is what upthrust or the force of buoyancy is. So it said that when any body is submerged fully or partially, so it is not required that it must be completely submerged in a liquid. Either it would be a submerged fully or partially in a fluid. Then this fluid will exert a certain amount of force on those body, and this force is going to be acted in the upward direction. This force this force is known as the upthrust force, or we can say it's a buoyancy force. I hope this is clear. So let's look at diagrammatically that how this situation will occur. That let's suppose that this is the spring balance, and as you are aware that spring balance is used to measure, it is used to measure the F is equals to mg. It's a weight. And let's suppose this is the object and it has been measured in its force, that means its weight in air. And let's suppose it is 120 into g. This is what we received as a reading. Now what we have done is that we have taken one of the container, and in this container let's suppose a certain fluid has been filled, and now we have submerged this body like this, so that just it is just submerged in this liquid. It is something like this. So only this segment of body is within the liquid and the another segment is within the air. So now weight I received is probably it's an 100 into g, which is less than 120 into g. Now what I have done is that again I have submerged this like this. Let's see what happens. That in one of the region I have submerged it something like this, that it is something like this, and in another situation I have submerged it like this. I hope this is clear. So does it clear both the situations? Yes. So here what weight I have reached on the spring balance measure, it's an 80 into g. Now you tell me what would be the reading of the spring balance in this case. This was the first case, this was the second case, this was the third case. What would happen in this third case? Would it be a 60g or would it be an 80g? What it would be? Yes, that what I received as a reading of the spring balance, it's an 80 into G. Surprisingly, it is same. Even though this has been just submerged, and this is the completely submerged. This is just below the level. Now, first thing, let's clear all this aspect one by one. That first thing is that when I have weighted it in air, it was 120 into G, and when I have weighted it in this situation, it is 100 into G. Why this has happens? Because Archimedes has this answer that what situation happen is that as this much amount is dipped within a liquid, so this total force, it's an mg in the downward direction. There is certain force which is in the upward direction, which we call as the upthrust force or a force of buoyancy. And this weight you rate is the amount of mg minus fb. So basically it's an apparent or virtual weight, what I can say. So same thing happens here over here, that this force, it's an mg, one more force, it's an fb, and what you read, it's an mg minus fb. But now the question, only the last question arises, that this has been this much submerged, this has been even this much submerged. So why the force of buoyancy acting on both are the same? So as we have gone through the many experiments, and from this we can came to the conclusion that force of buoyancy force of buoyancy depends on, first, directly proportional to the V in, it is the volume of an object submerged in the liquid. It is the volume of an object that is submerged in the liquid. Next, it depends on the density of liquid. It's a density of liquid, or I can say it's a density of fluid. And it depends on the G. It's an acceleration due to gravity. So basically this force of buoyancy depends on this three parameter. It depends on the V in. It is the volume of an object that is submerged in the liquid. It depends on the density of liquid, and depends on the G, which is acceleration due to gravity. So basically it depends on these three parameters. And if I check this practically, this is equals, that means no proportionality constant is required, and this is equals to V in into density of liquid into G. This is force of buoyancy, or many a times you will read this as upthrust. This is the force acted, this is the force applied by the fluid, force applied by fluid in upward direction always. I hope this is clear. So now I might assume that you get the answer of your this question, that why it is ATG and why even this is ATG, because both the blocks are completely submerged. As you can see, this has been this has been submerged completely, and when this has submerged completely in both the cases, V in the second case and V in the third case are equal. And when this both V in volume inside are equal, when this both volume inside are equal, that means they are having the same force of buoyancy. I hope this is clear. Have you got this? So do you understand this completely? Have you have you got this? Great. So this was the situation. Now one more thing is that let's suppose understood that Suppose we have the situation that, and according to the even the Archimedes principle, he states that the magnitude of the buoyant force is always equal to the weight of the fluid that is displaced by an object. Let's suppose what we have done is we have initially this was the situation and we have dipped this block into this. So from this we have an arrangement that from this water could coming out, and this water could be contained in one another container. So what we have seen it that as this has been dipped in this, as it has been submerged in this, a 3 liter of water, a 3 liter of water has been displaced, and this 3 liter of water has been received from here. So he states that the buoyant force is equal to the weight. It is equals to the weight of the liquid displaced. I hope this is clear. Is it clear? Is it clear? So when a body is immersed partially or wholly into a liquid, it experiences an upward thrust. That is what we understand, which is equals to the weight of the liquid displaced by the body. And here the upward thrust is what we call as a buoyant force, and it acts through the center of buoyancy. This is what we call as a center of buoyancy, which is center of gravity of the displaced liquid. We can also say it's a buoyancy is the ability or tendency of something to float in water or any other fluid. I hope this is clear. Is it clear? Is it clear? So now whatever we know from this we have capability to understand this law, and that is what we call as a law of flotation. So let's understood it in a very clear cut approach, because this will help us to get solved our numericals. Let's suppose this is the container and it has been filled with certain fluid. Now let's suppose one of the object is there, and I don't know that whether it is going to sink or whether it is going to float or what happens with this. But let's look that it is having one of the force. It is having the one of the force in the downward direction, that is what we call as an mg, and one more force which is having acting in the upward direction, which is equals to fb. So if I consider the first situation when mg is greater than fb, if it is that situation, while I say m, it's a volume of an object multiplied by density of solid multiplied by g. While I say fb, it's a v in, but here the object is been total within the liquid, it's a v multiplied by density of liquid into g. So if this situation persists, it's a v and g has been cancelled, it's a g and g. So this is the situation where density of solid is greater than density of liquid, and if mg is greater sorry, if mg is greater than the fb, that is force of buoyancy, then this object will sink. This object will sink if density of solid is greater than density of liquid. I hope this is clear. Is it clear? Is it? So always do remember this thing. If density of solid is greater than density of liquid, then your object is going to sink. Yes, is it clear? Is it? Do you have any doubts up till now? Is there anything? Is there? No? Now let's take, this was the first case. Let's take the second case, that this was the container, and this container is being filled with certain fluids, and this was the object. Now what amount of forces are acting? Let's have a look. That one of the force, it's an mg, another force, it's an fb, and now in this case it is the mg which is equals to fb. So from this it is something like this. This is v into density of solid into g. This is equals to v into density of liquid into g. If this has gone, and it is the case of density of solid equals to density of liquid. So this is the situation. Let's suppose that this object is will align itself something like this. So this object will arrange itself just below surface of liquid. So this object will arrange itself just below the surface of the liquid. This is the situation. This is the situation of the case when both the forces are equal and density of solid is equals to density of liquid. This even can be said as that this is the equilibrium. This is the equilibrium of fluid, that when both the forces are acting are same, that means this object is said to be in equilibrium state. This is the second law. And let's discuss the third and very important. It is the case that let's suppose this was the container. It has been filled with the fluid, something like this. And as it has been filled with the fluid, this is my object. This is the mg. This is fb. So in this situation, let's say if mg is less than fb, or I should say it's a v into density of solid into g, which is less than v into density of liquid into g. So this, then this has gone, this and this has gone. Though this means density of solid is less than density of liquid. So this, please do understand this. What happens is that initially mg is higher and fb is lower. So this object will starts oscillating when you first put this object into the fluid, and at last it will stable itself so that net amount of force, it's a net amount of force acting on it remains same. So net amount of force acting on it, it's remains zero. It's a net force. So that means mg and fb will be equal. So what happens if you have remembered that, please do this at your home, that take a bucket, uh, fill it with the water, take one plastic bottle which would be completely empty, and just try to submerge this plastic bottle into this bucket which is being filled with the water. So what you will observe that once you press it, once you press it within that water, what happens, just release it, it will jump it out. Again it will jumping down, it will jump out, jump down, and this will happen. So it will starts oscillating when you first put this into the fluid, but at last, at after certain fractions of seconds, it will stable itself such that a certain section would be over the air, and certain section would be within the liquid. We cannot certainly say that only this much amount will be above the liquid and this much amount will be below the liquid for every case, because each individual having a different case. And this is the situation when we say that object will float. I hope this is clear. So when density of liquid is greater than density of solid, I can say that my object is going to float. So so please do understand this. When they say when object floats, I can write it's an FB is equals to mg. This is what we write at after certain interval of time, or we can say that this is the statement at stable situation. But even one thing is clear, that we cannot see the transient situation and we cannot have the readings of it. So when I have been asked that your object floats, when I have been asked that your object floats, I will definitely understand that it is the case of the FB is equals to mg. I hope this is clear. This must be clear and there should not be having any confusion. I hope this is clear. So when they say that object floats, when they ask object floats, just do it. It's an FB is equals to mg, while FB could be written as V in into density of liquid into G, while mg, if required, it's a total volume. This is V total multiplied by density of solid into G. This is the mg. I hope this is clear. Is it clear? So please note it this too. This will require. This will require. Please note down this. Have you noted it? Have you noted it? Are you sure? Are you sure? Great. Now let's discuss. Let's discuss first the relative density. What this planning is, that just understand whole the situations, and then we will move to the questions based on this. So let's understand the one new word. It is the relative density, generally denoted as RD. It's a relative density. What it is? So when I say it's a relative density, we call this it's a density of a body divide by density of water at 4 degrees Celsius. It's a density of body divided by density of water at 4 degrees Celsius. Why at 4 degrees Celsius? Because at 4 degrees Celsius density of water, it's a 1 gram per centimeter cube. It could be lesser than this, at less than 4 degrees Celsius, even at the greater than 4 degrees Celsius. That is what we call as the anomalous expansion of water, and you have studied this. So it's a density of body divided by density of water at 4 degrees Celsius. Even when I say density of body, I could write it's a weight of the body. It's a weight of the body divide by it is the weight of water at 4 degrees Celsius. So it's a weight of the body divide by weight of water. But when I say weight of water, I should say it's an equal volume of water. Weight of water, but it would be of equal volume at 4 degrees Celsius. When I say weight of body divide by weight of equal volume of water at 4 degrees Celsius, I must say it's a weight of body divide by thrust due to water. I hope this is clear. It's a weight of the body divided by thrust due to water. And when this is the situation, this is the RD. It is equals to weight of the body in the air, that is weight in air, divide by weight in air minus weight in the water. I hope this is clear. So please keep noted this. Please keep noted this. This will help us a lot. This will help us a lot. I hope this is clear. Is it clear? Is it clear? Are you sure? Do you understand this completely? Yes? So can we switch on to the questions first? Let's have a look. If suppose someone asks me that, let's suppose a body. weights 160 into g in air, 130 g in water, and and 136 g in oil. What is what is specific gravity? What is specific gravity of oil? Specific gravity, it's a relative density. So how will I do this? How will I do this? I need to find out the specific gravity or the relative density of oil. So what I understood is relative density. It is basically a loss of weight in oil to the loss of weight in water. This is equals to this is equals to it's a weight in air minus weight in oil divide by weight in air minus weight in liquid. It is the same thing that we have did it. It's a weight in air which is equals to 160 into g minus of weight in oil. It's weight in oil, it's a 136 g divide by weight in air, it's a 160 g, and weight in water, this is the water, it's a 130 into g. So if I solve this, this relative density could be given as it was this 160 minus of 136 divide by it's a 160 minus of 130. This is equals to 24 divided by 30, and this is 6 into 4 divide by 6 into 5. So as this has gone, this is equals to zero point 0.8. This is the relative density of this oil. I hope this is clear. Is it clear? Is it? Are you sure? Do you have any doubts? Do you have any doubts? Are you sure? Great. Now, let's suppose look at the second question, that if an object floats in water with one third of its volume submerged in liquid, submerged in, sorry, or I should say submerged inside. If same object is submerged in another liquid having density of zero point 0.8 gram per centimeter cube, find out what fraction of volume is inside the fluid. How will you do this? So first look at the data. What did they all said? So the data said that let's suppose that if an object floats in water with one third of its volume submerged inside the liquid, okay, so it's a v in by v, which is equals to 1 by 3. Now if the same object is submerged in another liquid, and this another liquid is having a density of 0.8 gram per centimeter cube. They say that find out what fraction of volume is inside this fluid. It's a V in by V of this liquid has been asked. So first thing what I should look is they said it's a float, and when they say it that it is floating, that means it is the case at FB should be equals to mg. When I said it's an FB is equals to mg, I mean it's a V in into density of liquid into G. This is equals to mg, while mg it's a V into density of solid into G. This V will be the V total that you understand. Now, if you understand this very carefully, then you may came to contact that this G and G has been cancelled out, and from this it's a V in by V total, that is equals to density of solid divided by density of liquid. Initially it has been submerged in the water, and water having a density of 1, because even this is given in gram per centimeter cube, so it's a density of water. It is the density of water which is equals to 1 gram per centimeter cube. So this is equals to V in by V total, which is 1 by 3. Density of solid we don't know, density of liquid in this case it's a density of water, it's a 1 by 3. So density of solid it's a 1 by 3, or I should say it's a 0.33. Now please do remember this thing, V in by V total is equals to density of solid divided by density of liquid. This will help us, this is going to help us, please do remember this. Now the second situation is that what I need to find out, that what fraction of its volume is inside the fluid. So this is again V in by V. Now it's a time for the liquid. This is equals to density of solid divided by density of liquid. This density of solid it's a 1 by 3, and this density of liquid it's a 8 by 10, which is 0.8. So this is equals to 10 divided by 24. This is the V inside divided by V in this liquid. I hope this is clear. If they want in percentage, you can multiply it by 100. Now let's suppose in the same case I have been asked that what fraction of its volume outside the liquid. Then I will find this. It's a V out by V in this liquid is equals to 1 minus V in by V, and this is just 1 minus 10 by 24. So this will give me a 14, because 24 minus 10 it's a 14 by 24, and you can solve this further. I hope this is clear. So please do remember this, it's a V in by V total which is equals to density of solid divided by density of liquid. I hope this is clear. Is it clear? Is it clear? Great. Now let's look at the next question, very interesting. If an object floats in water with one third of its volume, outside the liquid, outside the water, sorry. If this container is arranged in a lift which is having accelerated motion in downward direction with acceleration of, let's say, 2 meter per second square, find what fraction of volume will be now outside the liquid? What will be the situation? How could you do this? They said that it's a situation when an object is there. An object floats in water with one third of its volume outside the liquid, outside the water in this case. And this container is going to be arranged in a lift. And this lift is having the accelerated motion in downward direction with acceleration of 2 meter per second square. We need to find out what fraction of volume will be now outside the liquid. So what I understand is that it was the situation when V in by V, that is equals to density of solid divided by density of liquid, and from this even I can have this V out by V, that is equals to 1 minus density of solid divided by density of liquid. So if you observe this V in by V or V out by V, it is not having the any relation. This fractions does not depend on acceleration due to gravity, acceleration due to gravity, or its variations, or its variations. So that means V out by V initial should be equals to V out by V final. I hope this is clear. So even after this accelerated motion, even after this accelerated motion, it will be a 1 by 3. I hope this is clear. So initially it was one third of part was outside. Even afterwards, this one third part will be outside the liquid. I hope this is clear. Is it clear? Now, do you have any doubts up till now? Is there anything? Do you have any doubts? Is there? No? Great. Now let's work for the next question. Very good questions can be asked from this. Let's have a look. Let's suppose this is the container, and this container is filled with the fluid. We have one of the object that has been tied with the string, and it is submerged within the fluid. So they will ask find out tension in the string. So initially the situation is this is at rest. Initially the situation is it is at rest. So what forces are acting? Let's have a look. One of the force, it's a tension, is acting on this. This is having mass m. So one downward force, it's an mg would be there. One upward force, it's an fb is there. And as they mention, it is at rest. As they mention, it is at rest. So this system is in equilibrium. So what I can have, it's a T plus FB, that is equals to mg, and from this it's a tension that is equals to mg minus of FB. I hope this is clear. Is it clear? Is it? Are you sure? Now let's say suppose the same container is moving in the downward direction with an acceleration a1, and this was the second question, that find out the tension in the string. How will I do this? As you observe that this is moving downward with acceleration a1, so it is pretty clear that mg would be greater than this too. Yes, so what I can write, it's an mg minus t minus fb is equals to m into a1, and as I want the tension, it is the mg minus of m into a1 minus of fb. This is equals to t, or it would be t is equals to m into bracket g minus of a1 minus of FB. This would be the situation. I hope this is clear. Even you got the same answer. Did you? Did you get the same answer? Are you sure? Are you? Great. Now let's move this in upward direction with, let's call it acceleration 2, and this is my third question. So this is the third question. What will be the situation now? The situation would be, as this container is moving in the upward direction, that means the forces that are acting in the upward direction would be higher as compared to the mg. So this would be the situation where T plus Fb minus mg, that is equals to m into a2, and from this it is T is equals to m into bracket g plus a2 minus of force of buoyancy. This is the tension force acting. I hope this is clear. So does it clear everything? Is it clear? Is it? Are you sure? A same kind of questions can be asked something like this, that let's suppose, look at this. Suppose this is the container, and this container is filled with the fluid. It is something like this. And now this is the object. This is the object, and this is the string. This is the string. So if they ask me find out tension in string, how will I do this? If they ask me find out tension in the string, what is to be done? So what I understand is that, let's suppose this is at rest, and if it is at rest, this is the case of T, even this is the mg, and this buoyancy is acting on the upward direction. So in this situation it is the Fb which is equals to mg plus T, and from this T is equals to Fb minus of mg. I hope this is clear. This is the tension force acting on the string. Now let's suppose if I move this in upward direction with acceleration a1. This is the second question. If I move this in upward direction, that means this Fb would be higher than the mg and tension. So this could be written as, it's an Fb minus of mg minus of T, that is equals to m into a1, and from this T is equals to Fb minus of mg minus of m into a1, and this is equals to Fb minus m into bracket g plus a1. This is the tension in the string. I hope this is clear. Is it clear? Is it? Are you sure? Great. Now let's look at the next instant when it is moving downward with acceleration a2. So now it is very easier to you that if this is moving in the downward direction, that means a force that is been applied by the mg plus T is higher than this. So it would be the case when mg plus T minus of Fb, that would be equals to m into a1. So from this it's a T which is equals to Fb minus it's an a2, sorry, minus of m into a2 minus of mg. So this is equals to Fb minus m into bracket g plus a2. I hope this is clear. Is it clear? Is it clear? Are you sure? So do you understand this? Yes, this is the normal laws of motion kind of questions that we can do. Only the thing that I must be clear is that where tension should be applied, it is always away from the body. Yes, that we have learned this in the Newton's laws of motion, and based on that we need to apply just the second law of Newton's laws of motion correctly, and that's it. You have did it. Great. Look at the next question. Now in this question the situation would be certain like this. Let's have a look. that this was the container, and as we understood that this container is filled with the liquid, this container is filled with the liquid, something like this. But this is not a same liquid on both the sides. That means, let me show it with different colors so that you may get. It is something like this. Yes, it is filled with two liquids having different density which cannot mix with each other. So this is a density 1 and this is a density 2. Now I have put object over here. Let's suppose it's a square and this object is having density of 3. This object is having a density of 3. What I need to do is, let's suppose this object is having length L, and suppose this has been immersed in first liquid having density 1 by the x amount. So it is obvious that this is the L minus x. So what actually happen is, they will give me the data of density 1, they will give me the data of density 2, they will give me the number of density 3, and they will ask that find out by what amount or what length will be displaced, will be within the first liquid, or what length would be in the second liquid, or what would be the ratios, what would be the ratios of this lengths and everything. But here we make it, we just understand the concept behind it, and I'm sure that by the data you will put it and you can get it easily. So let's suppose the question is find out value of the x. That's it. So how will I do this? What would be the situation? This is having mass m. So what I understood is that a force acting by the body in the downward direction, it's an mg, and it is at rest. This is fb1. It's a force acting by the first fluid plus force acting by the second fluid. Always do remember that every fluid in which object has been submerged will apply a force on it. Every fluid, you take a case of every fluid, that every fluid are there, they are going to apply a force. In this time my object has been submerged within this two fluids only, so only this two fluids will apply a force on it. If it has been submerged in n number of fluids, then this n number of fluids will apply n number of upthrust forces on this object. So the situation will be, it is the fb1 plus fb2, that would be equals to m into g. And when I say fb1, I should say it's a v inside 1 multiplied by density of liquid, it's a density of 1, plus g, plus fb2, it's a v in of 2 multiplied by density of liquid of 2 multiplied by g. This is equals to m into g. This is the v total multiplied by density of solid, which is density of 3 into g. From this g and g, that has been gone. Now v in 1, that could be written as area into length, or I should say area into height. So it's an cross sectional area A multiplied by x into density of liquid 1 plus it's a cross sectional area A multiplied by, it is the L minus x into density of 2 into g, that is equals to A into L into density of 3 into g. So this will be, this is multiplied by g. Sorry, I forget this to write down. It's a g and g has been gone, and from this it is just the case of A. Let me write this. It's an A into x into density of 1 plus area, and area. This has been gone. So it's an A into x into row 1, within which this A has been gone. It's a x into row 1 plus L minus x into row 2. This is equals to L into row 3. From this you can easily calculate this x. I hope this is clear. Was it clear? Was it? Are you sure? So can you do this kind of questions? Can you do it? Are you sure? Great. Now let's work on the next category of questions, which is the question based on the amount of substance, or we can say the questions based on the alloys. So let's suppose the data is given that an ornament weighs 60 gram in air and it's a 55 into g in the water. It's a 60 g in the air and 55 g in the water. Assuming assuming some copper is mixed with gold to prepare ornament to prepare an ornament. Find amount of copper in it. Specific gravity specific gravity of gold is 20 and specific gravity of copper is 10. So how will I do this? What is to be done? They said an ornament is there which weighs 60 into g in the air and 55 into g in the water. So it's a weight in air which is equals to 60 into g, and weight in water which is equals to 55 into g. Great. So assuming that some copper is mixed with the gold to prepare an ornament, find out amount of copper. Yes, it's a mass of copper is required. Mass of copper it would be required, and specific gravity, that is what we call as the relative density of gold is given, which is equals to 20, and the relative density of copper is given, which is equals to 10. This is all what they have given. So what should I do to solve this, or how will you do it? So what I suggest is that let's suppose let m is the mass of the copper. M is the mass of the copper in ornament. So if m is the mass, 60 minus m, 60 minus m should be the mass of the gold. I hope this is clear. Is it clear? So m is the, I should say m is the mass of the ornament, m is the mass of copper within it. Then 60 minus m should be the mass of the gold. Now let's suppose volume of the copper, which is equals to m by 10. Yes, it's a density. Basically, this is density is equals to mass by volume. So volume is equals to mass by density. And same way, volume of the gold, it's a volume of Au, which is equals to 60 minus of m divide by 20. I hope this is clear. Now this was the situation. Now let's suppose the situation is that when they have been put up in the water, that means it is the case when decrease in weight will be equals to, it's a upthrust force. So the situation will be, it's a 60g minus of 55g. This is equals to v1 plus v2 multiplied by density of water into g. So in this case, g and g, that has been gone, and from this it's a 60 minus 55, it's a 5, that is equals to m by 10 plus 60 minus m by 20. If you are going to solve this, it is the m that we received, it's a 40 gram. So this is amount or mass of a copper in it, it's the amount of copper in it. So the remaining, it is the gold, the remaining part is made up with the gold, and this amount is made up with the copper. I hope this is clear. Is it clear? Do you understand this completely? Are you sure? Are you? Great. So let's see one more question based on the mixtures. Let's suppose the question is, if we have liquid 1 having mass m1 and density rho 1 is mixed with another liquid, having mass m2 and density rho 2. Find density of mixture. This is the case. This is the question. That we have two liquids. One is having mass m1 and it is having the density rho 1. Another is having the mass m2 and it is having a density of rho 2. What I want a density of this mixture. How will I do this? So what I understand is it's a density which is equals to mass divided by volume, and from this it is the volume which is equals to mass by density. I hope this is clear. So from this what we understand is this volume V could be given as it's a V1 plus V2. So when I say it's a volume is equals to V1 plus V2, it's a mass, or the I should say it's a total mass divided by density of mixture. This is equals to first object mass, or it's a first liquid mass, sorry, it's an m1 divided by rho 1 plus m2 divided by rho 2. When I'm talking about the total mass, I mean it's an m1 plus m2 divide by density of mixture. This is equals to m1 by rho 1 plus m2 by rho 2. This is the relation, and you can put up the value and find out the data. Now, as in special case, if I assume that if m1 equals to m2 is equals to m, if this is the situation, then this could be written as m1 plus m2, which is equals to 2m divided by density of mixture. This is equals to m divided by rho 1 plus m divided by rho 2, and from this it's a 2 divided by density of mixture. This is equals to 1 by rho 1 plus 1 by rho 2. I hope this is clear. Is it clear? Is it clear? So from this please keep this in mind. If n number of liquids having equal mass, if n number of liquids having equal mass but different densities are mixed together, are mixed together, then density of mixture can be given as density of the mixture can be given as, that is n divided by density of mixture is equals to, it's 1 by density of 1 plus 1 by density of 2 plus 1 by density of 3 and onwards up to 1 by density of n. I hope this is clear. Please do remember this. This will help us a lot. I hope you understand this. Have you? Have you got this? Are you sure? Are you? Do you have any doubts? Do you have any doubts? Is there? No? A same kind of question, a same kind of question is that if we mix liquids having mass m1 and volume v1 with with another liquid, let's correct it, it's with density rho 1, with, if we mix liquids having density rho 1 and volume v1 with another liquid having density rho 2 and volume v2, find find density of mixture. How will you do this? Now you must attempt this. How will you do this? So what I understand is that we know it's a density is equals to mass by volume, and from this it's a mass which is equals to density into volume. From this it is something like this m is equals to m1 plus m2, and this is just the density of the mixture multiplied by v total is equals to density 1 into volume 1 plus density 2 into volume 2. So when it's a density of a mixture multiplied by total volume, it is equals to v1 plus v2. That would be equals to rho 1 v1 plus rho 2 v2. So it's a density of a mixture that is equals to rho 1 v1 plus rho 2 v2 divided by v1 plus v2. I hope this is clear. Is it? Is it clear? Now let's understand its special cases. If all the liquids having equal volumes but different densities, but different densities mix together, mix together, find density of mixture. That means in my case now v1 equals to v2 is equals to v. So it's a density of a mixture that would be equals to density 1 plus density 2 by 2. And if it is the case, if it is the case of the n liquids, then this density of mixture could be given as it's a rho 1 plus rho 2 plus rho 3 up to rho n divided by n. This is the density of the mixture. I hope this is clear. Is it clear? Is it? Do you understand this completely? Have you any doubts? Is there anything? Is there? No? Let's look at the certain quick questions. So it says that blank is the ability or tendency of something to float in water or any other fluid. Yes, buoyancy is the tendency or ability of something to float in water or any other fluid. Next, next question. Blank is the ratio of the density of a substance to the density of water at same temperature and pressure. Yes, specific gravity is the ratio. Specific gravity is the ratio of the density of a substance to density of water at same temperature and same pressure. Next, blank states that the magnitude of the buoyant force always equals to the weight of the fluid displaced by the object. Yes, it is the Archimedes principle who states this. I hope this is clear. Is it clear? Is it clear? So let's wind up the session over here. This was all about the Archimedes principle. Please go through this. We can say almost n number of applications can be derived from this Archimedes principle, and n number of questions can be formed from this principle. So please go through this concept and try as many questions as possible by you. Please do it. This will help us to get it done in a given time. Thank you. Have a good day. Take care. Bye bye.